which sometimes it is. So this is our last topic. So we're going to talk about how you can take complex numbers and write them in trigonometric form, and how we can use this to help us solve equations and to expand things more. But today it's kind of just like laying the groundwork. So today it's going to be like, it's so stupid, why am I doing this? And even tomorrow I'll say that too. But tomorrow I'll actually be able to say this is why we do this. So the first idea to make sure we understand is that a complex number is in the form a plus bi, where a is the real part and b is the imaginary part. Something you haven't thought about before is, hey, we could graph complex numbers. Instead of thinking about the x-axis and the y-axis, we can say the horizontal axis is the real axis, and the vertical axis is the imaginary axis. So let's make up a complex number. 2 plus 3i. If I wanted to graph 2 plus 3i, I'm just going to go over 2 on the real axis and up 3 on the imaginary axis. So I would get the point over 2, 3. Right? And that's 2 plus 3. The trig that comes in. Honestly, this relates right back to what we did with vectors. It relates right back to what we did with polar coordinates. It's just now talking about a and b instead of x and y, instead of r and theta. We're talking about this. But think about, for any point you graph, we'll go into a minute, but you could draw the angle that goes there, and you could make a triangle, and you could talk about the angle that goes with that point, and do all that stuff. So instead of talking about the, what do we call the distance of a vector, what do we call that? The magnitude. Instead of talking about the magnitude, same idea, but we can talk about the distance from the origin to that point that you graph. Guess what? We're going to find it the exact same way that we found the magnitude of a vector. We're using a and b here. I don't remember we used the vector. You're just going to take the square root of a squared plus b squared, which again comes from right here, that you could draw in the triangle that matches that. Well, the I part tells you that it's on the imaginary axis, but b is just the number. So like a plus bi, b is just a number. Okay? So some of it isn't so bad to do, like this. Plot 4 minus 2i, and then find, you need to know what that means. You need to know when you see that, oh, it just means the length, the hypotenuse. Right? 4 minus 2i. So 4 on the real, so over 4 minus 2 would be down 2. And then if I want to find the length there, right, you just need to know, it's just like the magnitude of a vector, it's just the square root of a squared plus b squared. It would be the square root of 4 squared plus 2 squared, or negative 2 squared. So 16 plus 4 is the square root of 20. And again, I want you to give me exact answers here, not decimal answers. So hopefully you feel pretty good about that, that you can break that up as 4 and 5, which would be 230. So that's graphing a complex number and finding the distance from the origin to that. And so now we can put all that trick back with it. And again, this should feel very familiar to you, that even though we talked about vectors and we talked about polar equations, and now we're talking about complex numbers, it's same format applies every time because all of these are just kind of like drawing angles. So I can do this over here for you. I'm going to put a point here. That don't apply to quadrant, but it applies anywhere. Obviously, the signs would change depending on where you are. But just like always, like you could draw this triangle in, and we could talk about this angle here. And the vertical side is always going to be the imaginary side, so that's going to be your B. The horizontal component is going to be the A. And then I think we're just going to call this R again. So again, we could just write these ratios. The cosine of that angle, cosine, is adjacent over hypotenuse. The cosine would just be A over R. Or if I want to solve for A, just like with vectors, I can multiply R over, and I can say that A equals R cosine of theta. Sine is opposite over hypotenuse, or B is the same as R sine of theta, which I think is exactly what we wrote out for the component form of a vector, changing it to the trig form there, like exactly the same. We could say tangent if we want. We could throw in the R, right? We could say A plus BI. The length is the same as R, which is just the square root of A squared plus B squared. Why are we doing all this? Well, we want to be able to change from our complex form and change that to trig form. So using that, if I have my A plus BI, I can replace A with what I know A equals, which is R cosine of theta. I can replace B with what B equals, which is R sine of theta. With an I then as well. So normally how we write this, we factor the R out, so we can say R times cosine of theta plus I sine of theta. And again, I put the I in front when it's sine. If you put sine of theta times I, right, it's the exact same thing. It's just whatever you feel better about. This is the way our book always writes it. In my Math 137 book, they condense it down more, and last year when I taught out of that book for the first time, I thought it was the silliest thing I ever saw. And I was like, this book just made this up. And then I read in the margins of our book, and I found it in here too. So I thought I would show it to you, and then it's up to you which way you write it. But they just condensed this down. So instead of writing this, because theta is going to be the same for both of these, right? It's the same angle. So they say R, and then they just like abbreviate it. So they use cosine, they use the C from cosine. They use the I because it's imaginary, and they use the S, so they say R CIS theta. And last year when I saw that, I went over to Mr. Alspaugh, and I was like, have you ever seen this ever in your life? And he's like, no, what? No. I was like, this is so stupid. And then I found it in the pre-cal book, and then I think I'm just really old, and I don't know, it's going to be math in the class. But in your book, 6.6, right over here, it says, what is CIS? And it says that they read it. If you look in the back of the book, they do not do CIS. Math 137 class with IB Tech, they use CIS, and on their tests, like it says, put in CIS form. And so I just wanted to show it to you. I'm not going to use it, but if you want to use it, you can. It is kind of shorter to write that. All right, so both of these are trig form of a complex number. Notice that trig form is also called polar form, not a coincidence, not unrelated to polar equations, but because it's the same stuff we're talking about with polar equations, except for we use x and y instead of a and b when we talked about polar. So trig form, polar form, are the same. So today we're just going to practice like going from one form to the other, some with a calculator, some without a calculator. Okay? So write in trig form. If it's from the unit circle, I expect no decimals. Alright? So if it works out that theta is an angle that we know, you shouldn't give me a decimal. Obviously, if it's some weird angle, right, then you have to give a decimal. And so that's where you have to kind of be aware of when can I give an exact answer and when can't I. There's a lot of work to show on these sometimes, and then sometimes you can kind of do it in your head, and I'll show you what I mean by that. But this is a plus bi, which means I know a is 2, I know b is 2, because I find r pretty quickly, or the, whatever we want to call this, a. R equals the square root of 4 plus 4, which is the square root of 8, which is 2 square root of 2. It doesn't require for you to graph it, but I think it's helpful sometimes because, one, depending on what quadrant you're in, changes your angle, right? And different things show up in the quadrant. So I always like to just roughly kind of think about 2 plus 2 over 2 up 2. That would be right here. I also like to graph it, because sometimes it saves me some work. Because I can say, if I go over 2 and up 2, what angle am I going to be at, you know? Degrees pi force, because I'm halfway, right? I'm equal distance. I kind of made a 45, 90 triangle here. So if you recognize that the angle is pi force or 45 degrees, you don't have to do the trig part. Like, you just know by graphing it. You're not going to always know. But especially when these are the same numbers, it's always pi force. If you're in quadrant 1, or if you're in quadrant 2, it would be 3 pi force. And so that's kind of a nice trick to be aware of. You didn't know that, right? You're like, there's no way I would get that. That's where you have to do sine, cosine, or tangent. I don't care which one you do. I usually just do sine. So if I was going to do the sine of this, right, sine is b over r, just 2 over 2 square root of 2. And again, you can draw the picture if you want. This is 2, this is 2, this is 2 square root of 2. Which hopefully you think of as a 45, 90 angle. Where you can use your calculator still, you can do inverse sine, and it should be in radians, pi force decimal, or if you're in degree mode, it should be 45 degrees. It's different than what we're used to because that square root's at the bottom. But remember, you can multiply the top and the bottom by square root of 2, and that's where you get the value that you're used to seeing in our unit circle. And so that's where you get. If you can figure out the angle without doing all that work, by all means, you don't have to do all that work. Because if it's the same distance on the x-axis as the y-axis, like it's always going to be like right in the center, which is going to be your pi force. Or the shortcut is, if you recognize that these are the same number, it's always going to be pi force, or if one's the same number, but one's positive or one's negative, it's just going to be a different multiple of pi force. And it's because, no matter what it is, if it's 7 minus 7i, if you went over 7 and down 7, it's going to be directly in the middle there. Right? It's going to be that line that cuts right through. So you can always just work it out. So if you know r, and if you know theta, that's all you need to write it in trig form. Trig form is r times cosine of theta plus I sine of theta. So once you know r and theta, you're just putting that in there. So you can say 2 square root of 2 times cosine of pi force plus I sine of pi. And it's the exact same thing as 2 plus 2i. And tomorrow we're going to talk about, well, why would we want to use trig form if it's the same thing? But if you work this out, if you took cosine of pi force times 2 radical 2, you're going to get 2. And if you took sine of pi force times 2 radical 2, you're going to get 2 with the I there. So it's equal to each other, it's just a different form. So this is the answer that I would give, or you can see why the CIS form This is what you would write if you were writing in that form. You would just write CIS, pi force. And so you can see that it's shorter, and you can see why maybe people that do this a lot have kind of condensed it down. Because if you know what that stands for, you don't have to write it all out. And so again, if you want to write it like that, I'm not going to mark you wrong. I'm doing that, checking the back of the book. Our book does it do that. They're all just like little threads. So this is one that, again, you could decide how much work you need to do. Here's what I mean by you might not have to do a lot of work, especially if it's just 4i. So it'd be the same as like 0 plus 4i. You with me on that? There's no a. Where would that be if I graph 0 plus 4i? Just up 4. So what's the angle going to be if it's on that imaginary axis? So if you can see that, oh, the theta is just pi halves, I don't actually need to do all that work. And what would r be in this? The distance from 0 to that point, it's just 4. And if you weren't sure that it was 4, I promise if you actually work it out, you would get the square root of 0 plus 16. And so this is one that kind of throws people off sometimes because it's just one part, it's just an A or a B, but it's actually one that you're going to do a lot of work on. So it's just r is 4, theta is pi halves, so we can say 4 times cosine of pi halves plus I sine of pi halves, or 4 CIS. And if you can think about it, cosine of pi halves is 0, so that's where the 0 comes from. Sine of pi halves is 1 times 4 is where you get the 4i. So that's kind of easy with it. Okay, the other thing we have to do today is go the other way, which is, I think, easier because you just actually work it out. So if they give me trig form, you're going to go back and put it in standard form, is what we did. So standard form is a plus bi. And again, if it's from the unit circle, I want exact answers, not decimal answers, all right? So 225 degrees, is that from the unit circle? Yes, which means unless you have one of those calculators that gives you radicals, which some people do, if you have a calculator that you type in cosine of 225 and it gives you a decimal, you've got to know the value from the unit circle, all right? So you just work it out. So 225... and I do much better in radians than I do in degrees, but isn't 225 just the pi force one in quadrant 3? Which is just negative radical 2 over 2, negative radical 2 over 2. So all you do is have to work that out and multiply the r through. So this is going to be 1/4, and the cosine of 225 is negative radical 2 over 2. Plus, I'm going to go ahead and distribute the 1/4. The sine of 225 is negative radical 2 over 2. And then don't forget that there's an I there. Question on where I got those values from? Well, I just needs to go somewhere, right? There's the I sign. You can put the I in front of the 1/4. The I can go up here, but just there's an I in this, so don't forget there's going to be an I in that second part. I always put the I in front of the trig value. Like if it's sine or cosine, I's in front. But if it's a number, I always put S in. So it doesn't matter. That's just how I do it. If you can simplify, obviously I want you to simplify, but I don't think this really simplifies, right? If you just multiply straight on top, you just get negative radical 2 over 8 minus radical 2 over 8i. And that's what I meant on the whole recognizing pi force. In standard form, all the pi force angles should have the same A and B values. And so even though that's kind of ugly, it's still kind of right once you realize that you did. And so that's it, standard form. Questions about that? is another one. This one's in radians, but still 2 pi thirds is from the unit circle. So all you got to do is find that point on the unit circle, plug in the value. What is the cosine of 2 pi thirds? What is the sine of 2 pi thirds? And then simplify. So -1/2 radical 3 over 2. If you have a calculator and you're not sure, you could always take the sine and the cosine of 2 pi thirds, right? One of them, 1/2 or -1/2 will kind of help you see that. So cosine is x, so that's -1/2, and then sine is radical 3 over 2. I don't know why I distributed on the last one and I didn't understand. Now I'm going to distribute. 10 times -1/2 is just -5. Plus 10 times radical 3 over 2, right? I could cancel the 2 out with a 10, and that's just going to become 5i radical 3. Again, the I is easy from here. I'm going to put the I there. I don't put it, the only reason I don't put it in the end, like it's just how I, when it's a number, like I always think it looks better to have this, but if it's a square root, and I wrote this, and I was kind of messy, right? So when it's a radical, I never put an I at the end of a radical because I write kind of messy, and I always am afraid that it's going to look like my I is under the radical, and it's not supposed to be under the radical. That's a very different thing. And so as long as you make sure that it's very obvious that your I is not under it, right, that's okay too. But you're right, I put an I in 3 different spots. So that's why I said it's just multiply by I, so wherever you feel like you want to put it, I promise. Put it in the front every time, put it every time. It's going to work. I didn't put one that's not from the unit circle, but those are just easier, right? So if you wanted to put something not from the unit circle, like you would just type it in your calculator, and you would just give decimal, which is an approximate. So we actually have some time to work today. It's not price time today. There's no more price time. I don't know if you know this or not, but we got an official email today that price time is forever over. So you actually have some time to work. So you can you start on this, ask me questions if you have them. And then tomorrow and Monday, we're just going to build on this, all knowing how to go from trig form to complex form. So make sure you get this done today, because that's tomorrow we'll figure out how to multiply. Drop this low jar of it. I thought was coming. Might be